Hi everyone, really happy to talk as part of SourceCon 2022, and today I want to talk to you about relationships and specifically the relationships that are formed when we design our services using a microservice architecture, and how it's really important that we check and verify the relationships, the communication pathways between all these different microservices. So before I get into it, I just wanted to introduce myself. My name's Thomas Shipley and I share ideas at my own website, my blog, Tom Driven Dev. So you can go have a look there if you want to. I also occasionally, but not very often, tweet at Tom Driven Dev. So if you have any questions after this session that you didn't think to ask during the session, I will be in the chat so I can answer some questions there. But if you're like me, they probably come up afterwards. You can always contact me on Twitter. And then finally, I work for a software consultancy called Global Logic in one of their UK offices. We're also looking to hire lots of testers within the UK. So if you want to talk to me about maybe working with me on some interesting projects, then definitely get in touch. So I'd like to start with a question. What is it that makes social networks so valuable? Why is it that LinkedIn or Facebook are worth the insane amount of money that they're worth? And to me, it's all about the relationships. It's the relationships in these systems that have value. If you think about it, if you have maybe a couple of individuals on one of these networks, you'll find out some personal information, maybe their name, their date of birth, and so on. And there is some value there for the advertisers that are spending all the money on these platforms. But actually, the value comes when you have millions of users all forming relationships with each other around their likes, their dislikes, starting to define their family and friends and their colleagues and clubs they're part of and so on. The real value for advertisers and why they spend so much money and these companies as a result are worth so much money is down to the relationships that are formed between users. That is what makes social networks so valuable. And so I'm going to ask a bit of a leading question, but what is it then that makes microservices so valuable? And to me, the answer is the same. It's the relationships. If we think about a microservice architecture, we have lots of services, and all on their own they do one individual or a couple of individual tasks. Maybe we have a payments microservice service that is just processing payments. Maybe we have a basket microservice which is looking after what a user wants to buy. Well, that's great and it's all functionality, but until those microservices come together, talk to each other, form relationships, that's when we start to see the entire system. That's when we start to deliver business value. Microservices on their own, the individual services, are not actually that valuable. They're a great way to structure and architecture our systems, but they don't deliver business value. It's only when those services come together, form relationships, that they deliver the actual system that we care about. So relationships are more important than microservices. So often when I speak to teams about testing microservices or testing a microservice architecture, they turn around to me and they talk about the individual microservices and how well they've been architected and maybe how well they've been tested with unit and component tests and so on. But actually the relationships are the most important part of a microservice architecture, because it's when those microservices communicate with each other that we start to see real business value. So that's where, as testers, we should be focusing our efforts on trying to catch some of the problems that happen within our system. But we're really bad at testing relationships. Some of the ways that we typically go to test relationships don't work very well. So I'm going to talk to you today a little bit about some of our usual techniques that we might try and why they're perhaps not so good, and how there is perhaps a better way of testing those relationships. So how do we test relationships? Well, we start off typically with two options: integration tests and end-to-end tests. And I've bundled them together because they're kind of similar to each other. End-to-end tests, we're checking that entire user flow all the way from the start of our system all the way to the very end. So if it's, for example, a website where we buy things, it might be starting off as an unregistered user, browsing the website, going through, picking the things we want, adding them to the basket, going into the payments process and the delivery process, maybe we sign up for an account and so on. It's that full process. And then integration testing is similar. It's just instead of going through the entire process, maybe we'll go through a subsection of the process. And maybe we'll go through adding items to a basket and through into payments and delivery. So we won't go through the entire thing of finding the items and so on. We'll just go through a subsection. But both of these options are quite slow to begin with. So they're slow because we're having to go through either the entire or partial user journey, and that is slow in itself. There's a lot of data setup that needs to happen, perhaps. We just have to go through that journey, and that takes time. But also they're slow because we often have to set up the environments that these tests run in. So if we're doing this in a really best practice type of style, then we're probably going to have to generate some of these environments on the fly before we run our tests, and that takes a bit of time as well. So they're quite slow. They're also brittle. They're brittle in part because we either are running on these generated environments and they can have their own problems, or we're running on these long-lived environments that lots of teams are sharing. And when you share test environments, that also can lead to problems where there's unintended side effects to one team changing something that impacts the testing of another team. But they're also brittle and fail often with false positives or false negatives because of how broad they are. An end-to-end test tests many different microservices and many different relationships between those microservices. So we're testing not one thing, but we're testing tens, hundreds, thousands of things potentially all at once. And so that by its very nature can be very brittle because it only takes a couple of things to fail and it all fails. And it's the same for integration testing, just at a smaller scale. So they're very broad, and because they're slow, brittle and broad, it also makes them very expensive. Because they're expensive to investigate for the failures, and they're also expensive to investigate applying the fix. So what about mocking? Quite often when I speak to teams, they tell me, well, maybe we can use mocks to solve this problem. But when you think about it, mocks don't test relationships. They remove relationships from your tests. When you use a mock, you are literally taking out a relationship between one microservice and another and replacing it with just this mock at the end, which is made up. It might be based on the real thing, but it's not actually the real thing. So you're removing that relationship. And also, I don't know about you, but when I create mocks for tests, I quite often will make a request to the actual service. I'll get the information, I'll bring it down, I'll put it into my test, and then I'll never look at it again. I'll never verify that that mock didn't go out of date. I won't look at it. And so quite often, those tests that use mocks and rely upon mocks of these different APIs can continue to pass even when that API has moved on and changed. New designs have come in, new features, new bug fixes and so on. That test is still frozen. It's still working off an idea of what that API should look like that could be very much out of date. And no one will ever check until that test fails. And one of the first things that happens is the person investigating the failure then has to ask the question, is the mock up to date? So mocks don't test relationships. They remove relationships from our testing. So what about contract tests then? Well, contract tests themselves have a bit of a circular problem when it comes to the traditional contract test. So imagine a catalog API team. They have an API where it provides catalog information to other parts of the system. And that team makes some assumptions as to how other teams will consume their API. And so they make this series of assumptions as to how other teams will consume and use their API. And they write those assumptions down in a contract test. They define the contract. But they've not gone and spoken to anyone about that. They've just done that as their own little team. They've sat down, they've thought about how people should use their API, their catalog API, how it should be consumed, and they write that down in a contract test, and then they run that contract test, and surprise to absolutely nobody, that contract test passes. And it passes because it just verified their assumptions. They've not at any point verified a relationship. In a lot of cases, the teams probably haven't even really spoken to anyone about how they might use their API. They've just gone in with a set of assumptions. So we've not tested a relationship here. In fact, when you think contract tests, I want you instead to think of circular tests. And circular tests don't test relationships because they don't talk to anyone who consumes that API. We've not considered our consumers really, we've just considered our own assumptions. But consumer-driven contract tests can fix these problems. Consumer-driven contract tests test relationships, and we'll dig into a little bit as to how they test relationships and how they do it so well. But as a high-level description, they test relationships so well because they're fast. We're still going to take advantage of mocking with our consumer-driven contract tests, but we're going to make sure that those mocks are verified. And so that makes our tests more robust because now we're not relying on mocks that go out of date, we're relying on mocks that are constantly being verified to make sure they're up to date and those mocks work in the same way as the service that they're mocking out. Our tests, when we test in a consumer-driven contract test way, are also tightly scoped. So instead of testing loads of things all at once, like we did with maybe the end-to-end or the integration tests, we're just going to test one relationship at a time. So we're going to test one thing at a time, the relationship between a consumer and a provider, the person that provides the API and the person that consumes the API. And that makes these tests very cheap. Once you understand how to write these tests on the consumer and the provider side, they become really cheap to maintain and run. If something goes wrong, well, we're not testing everything all at once, and we've got a mock that's been verified by the provider continuously. So if something goes wrong, there probably is a problem of some sort, whether that's technical or a communication problem. And finally, they're not circular. The clue is in the name, they're consumer-driven contract tests. The consumer is speaking to the provider and letting the provider of that API know how they intend to use their API. So now the provider has actual consumer feedback that they can rely upon during their testing. So let's go through a bit of a worked example of how these tests operate and how they verify relationships between a consumer and a provider. And so for this example, I want you to think of the provider as a team that works on a catalog API. This catalog API contains all the product information for a website. And so in there, you're going to have maybe images of the products, the price, maybe the amount that's in stock, maybe all this sort of information. And so that's the provider, and that's their catalog API. And on the other side of this relationship, we're going to have the consumer. And the consumer is going to be the iOS team. And the iOS team have an app that allows customers to come in, pick the items they want to buy, and pay for them. And as part of that app, they want to consume the catalog API. They want to consume this API and get all the information about elements that are in the catalog, all the different items that can be purchased. And so there's a relationship here. There's a relationship between the provider, that catalog API, and between the consumer, the iOS team with their iOS app. And we're going to test this relationship independently on its own, so not broad scoped, just one relationship is going to be tested, the relationship between that catalog API and the iOS app. And we're going to do it using 3 stages. We're going to write a consumer test, which is going to be written by that iOS team, where they are going to define how they interact with that catalog API. We're then going to have the second stage, where we share a contract file. So at the end of that test, that consumer test, we're going to generate a contract file. And then we're going to share that contract file into the third stage, which is the provider test, where that catalog team are going to verify that the mocks that the iOS team set up when they were running their consumer tests are accurate compared to the actual behavior of that catalog API. So let's go through that visually, because if you're anything like me, I'm very much a visual learner and pictures help. So let's start off over here. So we've got the consumer. So this is our iOS team, and they're going to write their consumer test, and they're going to write a mocked test. So far, this is no different to any other type of mocked API test you may have seen before. You've got this catalog API that as a team you consume, but you don't want to actually test against it during your unit testing maybe, so instead you're going to use a mock. So we're going to use this mock server, and the consumer is going to define all the different mocks they need, the types of requests and responses, the response codes, the data in the response, and so on. They're going to define all that, and they're going to run their testing as usual. And so you've got this unit style test with a mock server attached, mocking out that catalog API, and I'm just going to run through it. And then at the end of that testing, we're going to get this contract file. And this contract file, you can think of it like a forensic log. It's going to contain all the information about what happened with the mocks during that consumer test, during that iOS app test, and how it relates to the catalog API from the provider. So it's going to have all the information in there about what was requested by the iOS app to the mock server for the catalog API, what was expected back, the response codes, the response data, all of that stuff is going to be there. And so now that's in a contract file. And that contract file, as I say, you can think of it like a forensic log, like a really detailed log of everything that happened during that consumer side test when interacting with this mock server mocking out the catalog API. And so now the catalog team, they can take that contract file and they can have their own provider test. So they can look through this contract file and they can see that the iOS team, when they were using the mock server during their testing, mocking out that catalog API, they can see that they made this request and they expected the data response to look like this, with this format, with this many fields and so on, and the field should have this data and so on. And they can take that and they can replay that contract file request by response against the actual service. So they can go down the contract file and they can pick out the first request to the catalog API. They can make the exact same request to the actual service that they've got running, get the actual response, and they can check, does the actual response match the response that was used in the mock? And if they match, the test passes. That mock was valid, it's in date, it works the same way as the API actually works. So now we've tested that relationship. The consumer has had some fast tests on their side where they've managed to take advantage of mocking and check their functionality against a mocked out catalog API, but the provider has managed to verify that contract, that catalog API behaves in the same way as the mock. So that's really powerful. We've managed to verify that relationship asynchronously, both teams operating independently from each other, but reaching a shared conclusion. But importantly, if that test fails on the provider side, what if the consumer does something, they put in something in the mock server for the catalog API, which is unexpected by the provider and isn't how their service works? Well, at that point, their pipeline, if these tests are integrated in their pipe, which hopefully they are, is going to fail. And they're going to have to speak to that consumer. Because that's the important thing about consumer-driven teams. They talk to each other. When the provider's pipeline fails because they tried to verify the contract file and it didn't verify because the mocks inside of it don't match how that API works, then they can go over to that consumer team and speak to them about how they were working on it, why they mocked it out the way they did. And maybe there's a misunderstanding as to how the API works. maybe there's a feature that was expected to be in place where there isn't. They can talk about it. It drives conversation, which is really key. So how can you get started with consumer-driven contract tests? Hopefully now I've managed to maybe give you a flavour for how they work. You're maybe excited to try it out for yourselves, see if it works for your organisation and can help your team. Well, there's a few different ways right now that you can try this type of testing, but the one that I like is a framework called Pact. The reason that I like Pact is that it's open source, so you can dig into it, you can have a look at the code under the covers, it's all on GitHub, and you can get a real sense for how it works. It also supports many languages, which to me is a real killer feature. When we think of that example where we have the Catalog API developed by the Catalog team and the iOS team consuming that Catalog API, they could well and probably will be developing in different languages. Let's say the Catalog API team, they like to use .NET, they like to use C#. Whereas the iOS team, they like to use Swift and Objective-C. Well, that could be a problem, because what if those two teams had to agree to write the tests in the exact same language? Maybe that could be a source of conflict. Well, with Pact, that isn't the case. There's many different languages supported. That iOS team can write all their consumer tests using Swift or Objective-C, and the Catalog team can write all their provider-side tests using .NET C#. And the thing in the middle, that contract file, is all in YAML, so it doesn't matter. It can just be passed from test to test, and it doesn't matter which language that test is written in, it'll still work as expected. That's one thing to bear in mind when thinking of Pact. That example I just talked to you about talked about contract files, and in Pact they're called Pact files, but the concept is very much the same. You have a consumer test, which is a unit test with a mock server, which generates a contract file, a Pact file, and that Pact file is passed to the provider who verifies that those mocks work in the way that was expected. And then finally, the other thing I really like about Pact for this type of testing is that it comes with something called the Pact Broker. And the Pact Broker is going to help us share the Pact files, those contract files, between teams. Because as I was talking through that example, some of you may have been thinking, well, this sounds great, but how do we share those contract files between different teams? You know, some of us now may well be remote from the teams that we work with. How are we going to share them across different time zones and so on? This is something that the Pact Broker can help with. So let's talk a little bit about how we will share Pact files between teams. So there's three options when it comes to sharing Pact files between teams. We can share using the file system. We can share using a bucket, for example, like an S3 bucket from AWS. Or we can share using the Pact Broker. So the file system, firstly, is by far the easiest option. It's as easy as creating a folder on your machine and dropping all the Pact files in there, all the contract files in there, and telling everyone else to do the same. Put all your contract files in there, your Pact files, and we'll all just grab them from the same place. But that doesn't scale very well. What about permissions? What about conflicts and overwrites? It just doesn't work very well outside of maybe a small team all co-located. There's also no overview. One of the things that I'll talk about with the Pact Broker, which is really nice, is you get this really nice visual overview of how your system comes together, the relationships in your system, and the documentation that's generated from it. So you could use a bucket. So pick your cloud provider of choice, whether that's Google or Amazon or Microsoft, and use whatever options they have for storing files online, such as an S3 bucket for AWS. Now, this is really easy to set up, maybe not as easy to set up as just creating a folder on your file system, but certainly pretty easy. And so you can create that, and it does kind of scale. We can set permissions within our organization, we can maybe set some overwrite rules, retention rules, and so on, but it doesn't scale brilliantly, because how do we know when one Pact file, one contract file should overwrite the other? How do we know when one should apply, but actually now this one should apply? There's some deeper questions that you can't really solve just using a cloud-hosted bucket. And still, we don't get that overview. We don't get the visual representation of our system and how it comes together. So finally then, there's the broker, which is my preferred choice. It's really scalable because it's a API that you host yourself that is designed for managing this problem of sharing packed files between teams. You get this really nice relationships overview where you get to graph out all the different services that make up your microservice architecture, and you can see all the different relationships. You get some nice generated documentation, which is useful both for technical and non-technical members of the team, where you get to understand the depths and the detail of the relationship between two microservices. You also get webhooks. So webhooks allow you to integrate this really easily with your CI/CD pipeline. Maybe a consumer wants to notify a provider when they publish a new version of a particular contract, a particular packed file. Well, they can do that using a webhook, which might trigger their pipeline to straight away immediately verify it. So you're reducing that feedback cycle. So webhooks is a really powerful feature as well, but it is more setup. You are going to have to set this up and host it yourself. There is a Docker image that you can use, and if you know a little bit of Docker and you've maybe got the infrastructure already, whether locally or hosted in the cloud, then maybe you can put it there. But if that scares you off, there is also now a paid for hosted service called PactFlow from the creators of Pact, where you can just push all your Pact files there and they'll handle the actual managing of the broker for you, and you just get all the benefits. And so here's some actual examples, some screenshots that I took from the documentation for the Pact broker. On the left, you can see this really nice relationship map between all the different services, how they communicate and relate to each other. So it's really nice and visual. You get a real picture for your system. And then on the right, you can see an example of the documentation that's generated for a zoo app and an animal service and how they interact with each other, which is really useful for technical and non-technical people. So what technologies can I test with Pact? Well, we've already talked about HTTP APIs. That's a pretty straightforward example, but you can also use it with HTTP abstractions such as GraphQL, where the consumer is defining what fields they want in response back. Well, you can use Pact to verify that. You can also use it with messaging services, so putting messages onto PubSub or Kafka and making sure that they come off in the right way. And while I haven't done it personally, I have even seen some examples online of using this technology with a JSON document database, such as MongoDB, so something you could maybe research. So when would you not use Pact? So I wouldn't use Pact when a provider team won't write Pact tests. It's all very well for a consumer team to write consumer level Pact tests and generate that contract file, but if no one will verify that file on the provider side, then you've basically just got a mocked out API test. You might as well not have the overhead. So if your provider isn't willing to write those tests, which would be a shame, then that would be an instance where I perhaps wouldn't do it. Also, integrations with public APIs, mostly because you don't really control that relationship. You don't know how that is going to work, and so it's probably best left. And also teams with poor communication. If perhaps as a provider, a consuming team breaks your pipeline, you're going to want to talk to them and get a response fairly quickly so you can fix it. And if that's slow and laboured, then that's just going to be a cause of friction. So my experiences from using this with teams, there's no environment orchestration. We're not relying upon these long-running environments, which is really good. There's no slow or brittle tests because they're tightly scoped. We're only testing one relationship at a time, not loads of things at once. So there's not as much that can go wrong. So if they fail, it probably is an issue. But there is a network effect. You do need buy-in from multiple teams, and the more teams that buy into it, the better. So if there's only a couple of you, but the rest of the organization's ignoring it, that can kind of be a drawback. There's also a bit of a learning curve. This is still quite new to a lot of teams and organizations, so Prepare for teams to have lots of questions and want to learn more about it. Maybe you can send them this recording. And also another team can break your pipeline. But if you think about it, that's a really positive thing. You want to know when it breaks. So to wrap up, relationships are more important than microservices. Test your relationships and talk to each other. Any questions, please let me know in the chat. Otherwise, thank you for listening.